On a dark Atlantic night in 2009, an Airbus A330 with 228 people on board vanished without a distress call. It wasn't terrorism. It wasn't a catastrophic mechanical explosion. Instead, what unfolded was a quiet but deadly chain of events. A mix of weather, system quirks, and human factors that turned a routine overnight flight into one of aviation's most infamous disasters. This is the video of Air France Flight 447, a flight from Rio de Janeiro to Paris that disappeared on June 1st, 2009, and the lessons it left behind for every pilot in the sky. A night flight at the worst possible time. The three-man cockpit crew, one captain and two first officers, arrived in Rio after a Paris-Rio trip on May 28th. Their return flight was scheduled for 8 p.m. Rio time, which meant flying all night and arriving in Paris around noon. Anyone who's tried staying awake at 3 a.m. knows this is not peak human performance time. Pilots call it the circadian low, and it's a real enemy of alertness. To help with the long night duty, Air France added a third pilot. The captain, a seasoned 58-year-old with 11,000 flight hours, would rotate with two younger first officers. One with 3,000 hours but only 800 on the A330, and another with 6,500 total hours in deep A330 experience. On paper, that's a solid team. But as we'll see, experience doesn't always beat confusion under stress. Trouble ahead. Their route crossed the Intertropical Convergence Zone, a belt near the equator famous for powerful thunderstorms. These aren't your backyard summer storms. Some rise 60,000 feet high, well above where commercial jets cruise. They can also contain ice crystals invisible to weather radar. Think of it as flying into a dark room full of invisible marbles. Pilots knew this was a potential headache and loaded extra fuel to detour around storms if needed. But crossing the Intertropical Convergence Zone is always a gamble. You can plan, but you can't always avoid the weather. Meet the pitot tube. Airplanes need accurate airspeed. That's determined largely by pitot tubes, little probes sticking out of the fuselage that measure air pressure. They're heated to prevent ice buildup. But there's a catch. At high altitudes in the tropics, supercooled ice crystals can still overwhelm the heating and block them. Airbus and Air France had already seen reports of pitot tubes clogging temporarily. Newer, more resilient probes existed, but installing them wasn't mandatory yet. Ironically, the very jet operating Flight 447 was scheduled to get its upgraded probes when it landed in Paris. So we had long overnight flight, weather with hidden ice crystals, and pitot tubes known to sometimes get blocked. Not an ideal combo. A high-tech jet with a human twist. The Airbus A330 uses fly-by-wire controls. Instead of directly moving cables, pilots use side sticks that send electronic signals to computers, which then move the control surfaces. It's efficient and protective. In normal law, the plane won't let you stall or roll too far. But if the computers lose trust in their data, say because airspeed sensors go haywire, they drop to alternate law, a mode with fewer safety nets. It's like your car turning off traction control on an icy road. At altitude, this matters a lot. Jets are less forgiving up high. They have little excess thrust, stall at smaller pitch angles, and respond more twitchily to pilot inputs. Takeoff. Smooth sailing. For a while. Flight 447 left Rio at 10:29 p.m. UTC climbed to 35,000 feet and cruised uneventfully toward the open ocean. After takeoff, the relief pilot went to rest so the captain and the younger first officer could fly. Hours later, the captain swapped out, letting the relief pilot take his seat while he grabbed some sleep. The two remaining first officers were now alone, heading into the Intertropical Convergence Zone's clouds. Turbulence increased. They made a slight left turn to dodge weather, but didn't tell air traffic control. Not unusual in remote oceanic airspace. Lightning flickered. St. Elmo's fire danced on the windshield, and rain turned to ice crystals tapping the fuselage. The moment, everything went sideways. At 2:10 a.m., the pitot tubes iced over. The autopilot and autothrust abruptly disconnected with a loud warning chime. Imagine your car suddenly cutting cruise control on a slippery highway at night. Now scale that to a 200-ton aircraft. Instantly, airspeed readings went haywire. One display dropped from 275 knots to a nonsensical 60. Altitude briefly jumped down 300 feet because the systems were confused. Startled, the pilot flying instinctively pulled back, pitching the nose up. A natural move when you think you're losing altitude, but deadly if speed is falling. The jet began climbing rapidly, nearly 7,000 feet per minute, burning precious energy. The protections that normally prevent stalls had quietly switched off when the computers lost reliable data. The pilots didn't realize it. Confusion in the cockpit, alarms multiplied, master caution lights glowed. The flight mode degraded to alternate law, but that message was buried in a torrent of alerts. Procedures for unreliable airspeed existed, but weren't clearly cued. And the crew's training had emphasized low-altitude scenarios, not high-altitude hand flying in turbulence. The pilot monitoring tried to interpret electronic centralized aircraft monitor messages, but was rushed and unclear. The flying first officer kept his nose up, chasing altitude that wasn't safe. Neither pilot verbalized the word stall. Astonishing in hindsight, but understandable amid overload. When the captain rushed back a minute later, the jet was already deeply stalled, wings buffeting violently, falling thousands of feet per minute. Worse, the stall warning kept cutting in and out because of the odd airflow and speed readings. Each time they pitched down slightly the correct recovery, the warning screamed. Each time they pulled up and the wrong move, it silenced. It was, frankly, system design betrayal at the worst moment. The fatal descent. For the next 3.5 minutes, the A330 fell from 38,000 feet toward the Atlantic. Vertical speed hit 10,000 plus feet per minute, basically a controlled elevator ride down. The captain tried to make sense of the chaos, but hadn't been briefed on the initial trigger, the iced pitots and sudden climb. Commands in the cockpit were contradictory. Climb. No, go down. Toga power. Pitch up. It was too late, and dual side-stick inputs canceled each other out more than once. At 2:14:28 a.m., Flight 447 hit the ocean at a 45-degree nose-up attitude, but still descending at almost 11,000 feet per minute. The impact forces were unsurvivable. All 228 passengers and crew were lost. The long search and the hard truth. Initially, air traffic control didn't panic. Losing contact over the Atlantic wasn't rare. But hours later, search and rescue efforts began. Wreckage was spotted after 2 days, but the black boxes weren't found until 2011, nearly 2 years later, after a massive underwater search. When investigators finally recovered the flight data and cockpit voice recorders, the mystery unraveled. No catastrophic failure, no explosion. Just a small sensor freeze leading to a cascade of human and system missteps. Lessons learned. The official report concluded that ice crystals blocked the pitot tubes, causing a loss of airspeed data. The crew failed to follow the unreliable airspeed procedure because the cues were buried in chaos and training hadn't addressed this scenario at high altitude. Their initial pitch-up response drained speed and energy, leading to a stall they never recognized. Airbus's stall warning logic, which silenced at very low speeds, added confusion when clarity was critical, and the cockpit design didn't let the captain see the other pilot's side-stick inputs. As a result, airlines introduced upset prevention and recovery training, including high-altitude stalls. Airbus refined procedures for unreliable airspeed. Investigators advocated for cockpit video to aid future crash analyses. pitot probes were upgraded widely, and search and rescue technology was improved. Why this accident still resonates. Flight 447 isn't just a story about iced pitot tubes. It's about how humans interact with increasingly automated systems. The A330 was built to make flight safer, and it usually does. But when automation fails suddenly, pilots must instantly revert to basic flying: pitch, power, and keeping the airplane stable. That skill had eroded through over-reliance on automation and limited training for rare edge cases. It's also a human story. 2 pilots awake in the dead of night faced a flood of warnings, conflicting cues, and system quirks that would challenge anyone's mental bandwidth. One small misinterpretation, pitching up when they needed to level off, became unrecoverable in minutes. If you found this video as fascinating as I did, don't forget to hit that like and subscribe. Thanks for watching, and remember, no matter how complex the tech gets, pilots are trained to do one thing first: fly the airplane. Stay curious, stay safe, and I'll see you on the next journey.